All right. Today, we're going to pull back the curtain on the tech you use every single day. We're going to break down the code that powers, well, everything by basically building a program right here from the ground up. So, let me ask you a question. You're on a website, right? And that little chat window pops up. How does it know what to ask you? How does it seem to understand and guide you to an answer? You might think it's some kind of magic. But really, it's just pure, simple logic. When you really boil it down, a program like a chatbot is just having a very structured conversation with you. It's all about a series of questions and answers designed to figure out exactly what you need and lead you straight to a solution. So, if we're going to put a formal name on it, a chatbot is just software that asks questions, remembers your answers, and then uses all that info to help you make a decision. That's it. So, how do we actually build one? Well, you don't just start typing. It all starts with a plan. Before you write a single line of code, you have to create a blueprint. This is where you map out the entire thinking process of the program, and that blueprint, it has a name. It's called an algorithm. Now, the absolute best way to think about an algorithm is to think of it like a recipe for a computer. It's just a clear, step-by-step set of instructions you give it to solve one specific problem. And these recipes can look pretty different. See that on the left? That's a flow chart, a visual map for deciding what to have for breakfast. Do you want toast? Yes or no. Simple. And on the right, that's something called pseudocode. It's a text-based plan for our support bot. They look different, but they do the exact same thing. They map out the logic before the real work begins. And this is the part I really want you to remember. Great programs aren't just magically coded on the fly. No, they're built on really careful planning. That algorithm, that blueprint, it is the foundation for everything else. Okay, so our blueprint is done. Now we need the actual building materials, the language the computer can actually understand. And the most fundamental building block, the absolute first thing you need, is something called a variable. Seriously, just think of it like a labeled box. You give the box a name, and then you can put a piece of information inside it for the program to remember later, like a username or what problem a person is having. But here's the catch. These boxes are kind of picky about what they can hold. You have different types of info. A string? That's just a fancy word for text. An integer is for whole numbers. A float holds numbers with decimals. And a Boolean, well, that's super simple. It's just either true or false. And knowing the difference between these is absolutely crucial, as you're about to see. Okay, check this out. The program asks for two numbers. The user types in 5 and 3, and the computer says the total is 53. What just happened? The program didn't crash, but that answer is totally wrong. Any ideas why? It all comes back to those data types. By default, the program didn't see the numbers 5 and 3. It saw the text characters 5 and 3. So instead of adding them like numbers, it just smushed them together. That's a process called concatenation. It literally just joined the text. And the fix? Oh, it's so simple. We just add one little command, int, to our code. We're explicitly telling the program, hey, that thing you just got, treat it like an integer. And just like that, the computer gets it, adds them correctly, and we get the right answer, 8. Okay, so our chatbot can remember things, which is great. But what about doing the same tasks over and over again? Right now, our program is kind of inefficient. We need to teach it how to repeat itself. So imagine our bot needs to ask for your top 3 favorite subjects. This flowchart, it works, sure, but man, is it clunky. We're literally using the same ask for input and show output blocks 3 separate times. It's so repetitive and just inefficient. There's gotta be a better way, right? Of course there is, and it's one of the most powerful ideas in programming. It's called iteration, but you'll almost always just hear it called a loop. A loop tells the computer to repeat a set of instructions so you don't have to. Now look at this. This is the smart way to do it. This flowchart does the exact same thing as the last one, but it uses a loop. It just asks the question, checks if it's done it 3 times yet, and if not, it just loops back. It's so much cleaner. And here's the proof right here. Without a loop, it took 6 lines of code. With a loop, just 3. We literally cut the amount of code we had to write in half.
Now imagine you had to do something 1,000 times. See why loops are a game changer?
Okay, but wait a second. If our bot is looping and asking for 3 answers, where does it put them all? A regular variable can only hold one thing? Well, that's where our next tool comes in, an array, or what's more commonly called a list. It's just a special type of variable that can hold a whole collection of items, just like a shopping list.
So our program is getting pretty sophisticated. We've got a plan, we've got variables, we're using loops. But let's be real for a second. What happens when it breaks? Because trust me, in programming, things always break. Welcome to the art of debugging.
You know, bugs aren't all the same. You've got your basic syntax errors, that's just a typo, you forgot a comma or something. Then you have runtime errors where you ask the computer to do something impossible. But the really sneaky ones, those are logic errors. The program runs perfectly, no crashes, it just gives you the wrong answer, like our 5 plus 3 equals 53 problem. So how on earth do you find a bug that doesn't even tell you it's there? Well, here's the secret. You have to stop thinking like a human and start thinking exactly like the computer. You have to follow its instructions perfectly, one step at a time. And this right here is a programmer's secret weapon for doing just that. It's called a trace table. It lets us go line by line and track exactly what the computer is doing. So let's try it. On line 2, the variable called number gets the value 5. Got it. Next, line 3. It checks the condition. Is 5 less than 10? Yep, that's true. So since it's true, we move to line 4 and we output 10. See? By going through it this slowly, you can find the exact moment where the logic went off the rails. So when you peel it all back, from our simple little chatbot to the most complicated apps you use every day, what is it all really made of? It's just these simple building blocks, variables, conditions, and loops. It's just simple logic repeated and combined in these incredibly clever ways. It isn't magic, and now you know how it thinks.